Today, we are going to talk about limaçons. It's a French name. If you say limacons, I'm not going to throw a fit about it, but there's like limaçons. There's like some accents. I didn't type the accent. Okay, but there is, yeah, there's a squiggle somewhere. Okay, what I need you to do is I need you to write down that this is the form of a limaçon. Okay, you're going to have R equals A plus or minus B sine theta, or R equals plus or minus B cosine theta. Okay, so technically there's 4 different ways we can make a limaçon. Okay, you're going to have the plus or the minus, not both. I just don't want to separate them out. Okay, well, yesterday we talked a little bit about sine and cosine. What did we talk about the difference between sine and cosine? What did that determine? Okay, up and down, or right, left, right? So sine or cosine is going to determine the symmetry.
Okay. Determine symmetry.
Yep, I did. Thank you.
Failing grace.
Okay, so sine and cosine, that's going to determine symmetry. Similar to the plus and minus of circles yesterday, plus and minus is going to determine where a majority of the limaçon is going to be. So circles, yesterday, it was either to the right or to the left, and either up or down from the pole. When we draw limaçons, not all of it will be to one side, but there's going to be a majority of it on one side or the other. So positive is going to tell you it's either going to be up or to the right, just like we talked about in circles yesterday. Negative is going to be either down or left. It all depends on if it's paired with a sign. Okay, sine is going to mean up or down, like you just said. So if it's A plus B sine of theta, a majority of the limaçon is going to be above the pole. Okay? If it's A minus B sine of theta, a majority of it's going to be below the pole. And then the same thing with cosine, right and left, with the positive and the negative. Okay? A plus B. A and B, if we add them together. Any ideas what that's going to do? You didn't quite figure that out in your discovery?
Nope.
What's something I make you identify on that list? This is going to give you the max R value. Okay? So it's going to kind of play into where a majority of our curve is. That's going to be where your max R value is, right? So if you have A plus B cosine theta, a majority of your limaçon is going to be to the right. Specifically, it's going to be A plus B to the right. Okay? A divided by B, this is something that you may have looked up in that discovery activity. How many types of limaçons are there? There's 4. Okay? And so A divided by B is going to determine the type of limaçons. And we're going to go through each type and what they're going to look like. Okay? What's nice about the limaçons is we are always going to plug in the same theta values. Okay? When we graphed roses, we plugged in 0. And then we had to figure out, do we know where the petals are? Do we have to figure out where the petals are? With limacons, we're just going to plug in the same values every time, okay? So the thought process is going to be easier there, but we do need to be able to determine the type. There's 4 different types, okay? So when I move to the next slide, there's going to be 4 different pictures. My suggestion would be to wait and draw the picture until we describe like what its name is and how to find it, okay? So don't draw all the pictures quite yet. We'll draw one at a time, okay? But I just want you to like really appreciate. Okay.
Wow.
They look like lima beans, is that what you said? Okay. All right, so let's start with this one. What does it have that the others don't? There is a loop. Guess what? That is its name. And we have a loop if the ratio of A to B is less than 1. If the ratio of A to B is less than 1, we have a loop. Okay? What does this one look like?
B.
It looks like a heart, I think, because it comes to that point. It is a cardioid. And is it C-A-R-D?
Yeah.
Okay. I always want to put a T there. It is a cardioid because it looks like a heart. I mean, it doesn't look like exactly what you would draw, but it has like that that point, right? And this happens if A divided by B equals 1. So what does that mean about A and B? They're the same. When A and B are the same, we have a cardioid. Okay? And I will forgive you if you spell this wrong. In fact, it could be spelled wrong on the key. Just go with it. I think I put a T instead of a D right there.
Oh, no, it's okay. I think there's supposed to be an I.
Is there,
I think there's an I after the O.
you know what,
Yeah, you're right.
okay, there's another I. See, it's just,
It's okay.
it's a lose-lose for me here. Okay, cardioid, just sneak in an extra I. Thank you.
Yeah.
All right, now, if you compare these two, okay, the cardioid ones that comes to a pretty hard point, but this one doesn't. Okay, this one kind of looks like the little indent in your cheeks. What are those called? Yeah. This is a dimpled. Okay, it's like you have this ball of Play-Doh and you just like stick your finger in it. There's like a little dimple. Okay. Yep. This happens when A divided by B is between 1 and 2. Okay. Notice, however, the dimpled limacon, does it go through the pole?
No.
It does not. Okay. Our cardioid did and our loop did, but the dimpled does not. So when you're drawing it, make sure you take note of that. Oh, what did you just say?
So there's no zeros?
There's no zeros in this one. That's exciting,
Yeah.
because that means we don't have to find them. One less step. Okay, now,
Yeah.
how does this one differ than the dimpled one? Okay, do you notice how these other ones, they cave in a little bit? This one doesn't cave in a little bit. It's convex. And this happens if the ratio of A to B is bigger than or equal to 2. Okay. Now, in order to remember the order in which these are named, maybe you want to come up with some sort of phrase, okay? to remember loop, cardioid, dimpled, convex. Okay. The phrase that I learned to remember these, I'll share with you. You can think it's totally bogus and come up with your own, or you can use it. Okay? What I learned is Lou loves dimpled cuties. You don't have to use it, but that's how I remember the order in which these come. Okay? So, also what I want to point out, all of these pictures that I had you draw, these are all A plus B cosine theta. Do you notice how they don't open, but the graph is mostly to the to the right of the pole? Okay, these are all A plus B cosine theta. So when we have different versions, those are going to rotate a different way, but at least the overall picture you have written down in your notes. Okay? So we are going to go through 4 examples for each. When we draw these, you don't need all of the diagonal angle lines for our polar. Okay? We really only need to worry about the vertical and horizontal axis. I know that will make you happy. So, go ahead and write down this first example for me here. And to be honest, I don't think in your notes you need to worry about the concentric circles. I think as long as you make tick marks on your horizontal and vertical axes, you should be fine. You should be able to tell what's going on. Okay? So write down the curve, r equals 2 plus 3 cosine theta. Draw your horizontal and vertical axes. And then I want to give you about 60 seconds to discuss at your pod what type of limacon is this and what direction is it going to face. Okay, where's the majority of the limacon going to go? 1, 2, 3, go.
Well,
Yeah, I think it's gonna open right. What? To the right. What?
Between 1 and 2.
Oh, I think it's sure.
Yeah.
Okay, so back up here. When I ask you for the shape, just like I did yesterday. Yesterday I asked you for the shape, you put rows and then how many petals. Here, when I ask you for the shape, please specify that it is a limacon, but then also the type. Okay? So, Emma Ralston, what is our shape? And how do you know that it's a loop? Okay, here's A, here's B. 2 over 3 is less than 1. We have a loop. Okay? The direction that a majority of this loop limacon is going to be would be what, Monique? To the right. We have plus in between A and B with a cosine. Cosine's telling us left or right. That positive is going to choose the right. Okay? The max R value. The max R value I told you would be A plus B. Well, what is that? 5. Okay? We'll come back to the number of zeros after we plug in our significant points. Here is the wonderful thing about limacons. I am going to ask you to plug in 0, and then pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. Every single time. What did you say?
Isn't that wonderful?
It is kind of nice, right? First of all, they're easy points to plug in, and you don't have to think about it. You just know those are the points you're going to plug in. Yesterday, you had to do some work to find where your rose petals were. Okay? So, 0. What is the cosine of 0? It is 1. So we have 2 plus 3 times 1.
Like that.
Okay? Pi over 2. What is the cosine of pi over 2? 0. So we have 2 plus 3 times 0. So at pi over 2, we're going to move out 2. Then we move on to pi. What's the cosine of pi? Negative 1. So we have 2 plus 3 times negative 1. Okay? Everyone watch up here, please. We're going to rotate to pi and then move backwards. 1. Exactly. Thank you. Riley, say that louder. We got to get the loop. That's where the loop's going to be. Okay? 3 pi over 2. What's the cosine of 3 pi over 2? Thank you, Max. So 2 plus 3 times 0 is 2. And then, guys, when we plug in 2 pi, it's going to be the same exact point as when we plug in 0. So we're going to end up where we started. Okay. Start at theta equals 0. And then does our loop go through the pole?
Yes.
The loop goes through the pole. I'm going to be picky about that.
Yeah, it is how.
Okay. Make sure that loop goes through the pole and it comes out a little bit more than those vertical points. Okay. It doesn't have to be perfect, but I will take off points if you don't go through the pole or if you make this a corner right here. This needs to be nice and smooth. Okay? This needs to be nice and smooth. Okay? How many times did we go through the pole?
Twice.
Okay.
Twice.
So we have 2 zeros.
Where do we have to find them? Because I don't see a spot.
Riley does not see a spot for zeros.
Oh, nice.
When I have you graph a limacon, I am not going to ask you to find zeros because, don't write this down with me, but if we were to set this equal to 0, we would get the cosine of theta equals negative 2 over 3. Without a calculator, you're not going to be able to tell me that because that's not a unit circle ratio. So, since you don't have your calculators and that's not a unit circle ratio, I'm not going to ask you to find it. Okay? So, one less thing you have to do for a limacon. Tell me the number of zeros, but you don't have to find it. Okay? Did you have a question, Ashley? Okay. All right. Before we move on to the next one, is there something that I need to clarify for you? Yes.
So we just use the same 5 points for theta every time.
Yes. Anytime you have a limacon, these are the 5 coordinates you're plugging. These are the 5 values you're plugging in for theta. Okay. Nice, right? Don't have to think out of the box at all. All right. Let's do another one. Okay. Once again, write down the equation. Draw a vertical and horizontal axis. Just since it's your notes, I don't think you need the concentric circles. You'll get the practice on this grid in your homework tonight with your worksheet.
I'm impressed.
Once you get your axes drawn and the problem written down, go ahead and determine the shape, the direction, and the max R value.
That's A minus.
Okay, something that I should clarify. This is A minus B. So A is 4 and B is 4 and there's subtraction in between.
Got it.
Okay? So Addison M, what kind of limacon are we dealing with? And how do you know that? Okay. Here's A, here's B. A divided by B, A divided by B equals 1. So we know we have a cardioid. The direction of this cardioid is going to be... I don't know what that was. Dallas, what's the direction of this cardioid? Okay, it's going to be going majority down because we have subtraction with the sign. And our max R value, Emily B. It would not be 0 because we're going to think of B as 4.
Okay.
So instead it would be 8. Okay. A subtract B. So A plus B would be 8. Okay, 4 and 4. All right, so here we go. I am going to have to count by 2s up here if I'm going to get this to fit. You can do whatever you need to on your notes, but that's what I'm going to have to do up here. All right, if we plug in 0, the sign of 0, everybody?
0.
0. Let's try that again. The sign of 0?
0.
So we have 4 minus 0. Okay. Pi over 2. The sign of pi over 2 is 1. So we have 4 minus 4 times 1. Well, that's kind of strange. What's happening there? That's where our corner is going to be. Okay. Okay. Pi, the sign of pi is also 0. So we have 4 minus 4 times 0. So at pi, we're going to go to 4. Okay. And then 3 pi over 2. We know that the sign of 3 pi over 2 is a negative 1. So we have 4 minus 4 times negative 1. Here's where we get our 8. That makes sense. We knew a majority of this was going to be below the pole. So 2, 4, 6, 8. And of course, we end where we start. Okay? So in order to draw this for the cardioid, you do need that hard corner. This is the only time you get to make a jagged corner. Okay? I mean, it's not the prettiest, but I'm flexible. I know that these don't have to be perfect. Just make sure they're smooth with a corner there at the pole. How many times did we touch the pole? We touched the pole once. We have only 1 0. We could find it. We know that our 0 is at pi over 2 because we found it right here. But in any limacon, I'm not going to ask you for what the zeros are, so you get a freebie. All right, we have 2 more examples. Hang in there, people.
Blue.
Blue is right.
Yeah, it was kind of like a slow one.
Okay, write this example down. R equals 4 minus 3 cosine theta. draw your X and Y axes. Austin, what type of liaison do we have?
Dimple.
We have a dimpled. A divided by B is bigger than 1 but less than 2. So we have a dimpled liaison. Okay? Emma Stock, where is the majority of this going to be? Why down? Okay. I like the subtraction. But keep in mind what this does. There we go. Okay, since it's cosine with the subtraction, we're going to be to the left of the pole. And really, that's more to check to make sure your graph is okay. All right. Our max R value. Guy, what's our max R value? 7. Okay. 4 plus 3 is 7. Here again, I'm going to have to count by 2s. Okay, that would be a 4. Okay, I am going to give you about a minute and a half to, at your table, go ahead and plug in our 5 critical points. I want you to practice without me getting these values. Don't plot them on the curve in case they're wrong, but find those 5 values. Are you stretching? Yeah. Okay. Aaliyah, what do we get for R when theta is 0?
1.
When theta is pi over 2, Mara. For pi over 2? What did you say? 4. I thought you said 1. I'm sorry. Okay. Sorry. Okay. Jessica, pi. Kaya, 3 pi over 2. And at 2 pi, we end back at 1. So we have 1, 4, 7, 4. Okay, so here you need to make sure that everything is smooth and that we see this dimple, but there's no hard corners. That's the biggest thing. This is the toughest for me to draw, I think. So you got to make that dimple without any of the corners. So make sure I can see that it dips in a little bit and try to make this symmetric. Mine's not very symmetric, so it's bothering me. Okay, that's still not any better. Okay, how many times do we go through the poll? Okay, so we are going to have no zeros. Okay, so instead of writing the number 0, I'd appreciate if you would write the word none. Don't leave it blank because I'll think that you don't know the answer. But write none, so you don't think that, I don't want you to think that 0 is a 0. So I would prefer that you not write the number 0, but instead give me the word none. Okay? Okay, you know what? I don't think that we need a fourth example.
Okay.
Okay? Yes.
When you plug in the points, do you always, if you're gonna A plus B, like, is if you plug in pi,
So when we plug in pi, the cosine of pi is -1. So we have 4 minus 3 times -1. It changes it to a plus. Does that answer your question? Okay. So the only one that we didn't graph together was a convex. Just make sure that when you graph it, like to me it kind of looks, I mean it's as close to a circle as we get, but it's not circle-ish. Just make sure you make it nice and round. And it kind of looks like right here on that, the shorter side, it kind of looks like a ball of Play-Doh that you set on the table and it kind of settles, like it flattens out a little bit. So just make sure you make your graph look like that, okay? I am going to hand out your worksheet. And what did I tell you about the key? Where will you be able to find it?
On your web.
On my website.
Just think if I would have done one more 100%, I would have been able to finish this one. So, thank goodness I didn't do some. Yeah. This is such a slack sometimes. I just listened to that. No, row echelon.
All right. Tomorrow, you're going to come and we're going to, hey. Listen. Tomorrow you have like a 4-question quiz, okay? I want to see what you can do with these graphs. So if you didn't do your rows assignment, maybe doing at least some of it tonight with these limaçons, that might be a good idea, okay?